Hi, this is Mrs. Kidman, and I am so excited to be talking to you today about how to factor using grouping. So as just a quick refresher, when we're talking about what we mean by factoring using grouping, is we are going to group terms together within a single polynomial and then factor things that are in common out of those. So let's start by reviewing over what factoring is, or what we can factor. So we want to look for the greatest common factor between two terms. So here, let's start out with this 6x squared minus 9x. So to find that greatest common factor, what I want to do is look for a number that's going to be in both of these terms. So for example, 6 and 9, well, 3 goes into both of those. An x squared and x, well, an x goes into both of those. So I factored those out. I pulled a 3 out of this and a 9 out and an x out of it. Now what's left? So here I had 6, I pulled 3 out, 6 divided by 3 is 2, and I took one of those two x's, so I still have one x left. Now over here with my 9, I pulled 3 away from that 9, so 9 divided by 3 is 3, and then I took that x. So as I factored out that 3x, notice that I still had a 2x minus 3 inside. So that's how we would do it if it was a variable, if it was a coefficient that we might have in common, something that we can factor out there. Now, in this next example, we aren't going to factor out an individual variable or number, but in this case, we're actually going to factor out a polynomial. So look at our two terms here in this polynomial. I have x times x minus 2 and 3 times x minus 2. Notice how both of these have this polynomial of x minus 2 contained within them. I can factor that out. I can pull that x minus 2 out. So as I pull that x minus 2 out, what do I have left over here? Well, I have an x plus 3, and that's it, right? I have an x here, and I have a plus 3 here. And remember, I multiplied here, so I want to keep this multiplication there. So notice that I can factor out this x minus 2 and get x minus 2, and then whatever's left over, that x and that plus 3, we combine together here. We can do the exact same thing with this problem. Notice how we have that 2x minus 5 in both of these terms here. So I have term 1, term 2. I have an 2x minus 5 in both of those. So because I have that, I can factor it out and I get 2x minus 5. And then that's going to be multiplied by whatever's left over, a 7x squared and a negative 11. Now the reason that this works is remember back to when we learned how to use that distributive method for factoring. So we had something like this. Imagine if I had something like 7x squared minus 11 times our 2x minus 5, right? When I did that distributive method, I took this term and multiplied it by that whole polynomial, and then this term times that whole polynomial. Notice how I wrote 7x squared times 2x minus 5 minus 11 times 2x minus 5. Notice how this and this are the same. That's because what we're doing here is we're actually, when we're factoring, we're doing the opposite of that multiplication. So as we continue to solve this, we can actually go in the opposite direction. So here, I would continue to solve this and I would get 14x cubed times negative 35x squared minus 22x plus 55, right? This would be in that standard form. So when we're going from this factored form down to this standard form, we are multiplying. However, what we're talking about today is how we go from getting something that's in this form and we go back the other way. Going back that other way is called factoring. Okay, sometimes we interchange that multiply with a distributive property. So we distribute, right? So the opposite of multiply or distributing is factoring. And factoring means that we're going to group and pull out. So that's what we're going to talk about today, is how we would group and pull out. So when we're doing this factor by grouping, notice how we have to have at least 4 terms. We're only going to factor by grouping when I have 4 terms here. And the way that I'm going to factor these is I'm actually going to group my parentheses just like this. So in the middle, there's a little 5 here. So really what I just did is I said 5x cubed minus 4x squared plus negative 15x plus 12. Okay, I just separated those. I grouped them up. I always want to group up the first 2 and the last 2 to start. I want to see what happens. Now I want to, so I grouped them up. So step one, group. Those parentheses are kind of like decorations. They don't change our problem. We just put them in there and make them look pretty. So first we want to group. Second, I want to find that greatest common factor and I want to factor it out. So let's look here at this 5x cubed minus 4x squared. What's our greatest common factor here? Well, I've got a 5 and a negative 4. Well, 5 is prime and it doesn't go into negative 4, so it doesn't work. But I have this x cubed and this x squared. So I can factor out two x's. So here, I'm going to factor out two x's, and what's left over? Well, a 5x minus a 4. Now over here, I want to look at the same thing. What can I factor out here? Now notice, remember up here how I had two terms that were the same? 2x minus 5 and 2x minus 5. Do you see how this first step looks a lot like this term up here? I want to make it so that I can factor out this 5x minus 4, which means I want to see, is it possible for me to factor a number out of here and get it to look like 5x minus 4? And I realize it is. That number that I need to factor out here is going to be a negative 3. If I factor out a negative 3, negative 15 divided by negative 3 is 5, and we leave that x, and 12 divided by negative 3 is negative 4. So now look, I have this term that's the same as this term. So if I have those two polynomials that are the same, what can I do? Well, I can factor them right out, and I get 5x minus 4 times whatever's left on the inside, x squared plus negative 3. So that's kind of how we factor by grouping. Let's take a chance to look at what happens next. So our steps here, we grouped them. We found the greatest common factor between each of them, and we then factored out, the new GCF, which in this case was our binomial. And when we're doing this factor by grouping, we always want to try to factor out a binomial in that third step. And then lastly, we factored completely. So a lot of people will try to stop right here at this step, but that is not factoring out completely. We have to go all the way to this last step. So let's take a chance and look at this next one. 24x cubed plus 6x squared minus 20x minus 5. Okay, so I'm going to group them. Bam, 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 bam. Right, so here we go, grouped. So now I have 24x cubed plus 6x squared plus negative 20x minus 5. Now I'm going to start by grouping this first set over here, and I want to look at what is the greatest common factor. Well, I can pull a 6 out of both of those. I can also pull two x's. So I'm pulling out a 6x squared because I have an x cubed here and an x squared there. And what's left over? Well, in this first term, 24 divided by 6 is 4, and x cubed divided by x squared is just an x, plus, what do I have left over here? Well, 6 divided by 6 is 1. X squared divided by x squared is 1. So I have 4x plus 1. Now remember on that last video, I want to make sure that these two terms are the same. So what do I have to factor out of this? What is a common factor that I can pull out that'll give me a 4x plus 1 on the inside? Well, I know that 5 goes into both negative 5 and negative 20, but they're both negative. So negative 5 also goes into both of those. So if I factor out a negative 5, negative 20 divided by negative 5 would be 4x, and negative 5 divided by negative 5 is a plus 1. So here we are. We've separated it out. Now I can look at my two binomials, and they're the same, right? 4x plus 1, 4x plus 1. So I can factor out that binomial, 4x plus 1. And then what are the two terms that we multiplied it by? I have a 6x squared minus 5, because that's our minus 5 there. And that's how we factor that completely. So I want you to take a second, practice factoring this out using grouping. So the way that we're going to do this is pause the video, practice this problem on your own. After you've completed it by doing factoring by grouping, unpause the video. I will have a solution up here, and I want you to check to see if your solution matches mine. So pause it. Okay, hopefully you had the chance to pause the video and try this on your own. Now, as we come back and look at it, we first start by grouping. Remember, I want to group those first two terms and then the last two terms. And as I group them, I then want to look for what is my greatest common factor. And so as I looked for my greatest common factor in this first one, I saw 4 goes into both 12 and 32, and x squared goes into both x cubed and x squared. So I pulled out a 4x squared, and what was left over gives me a 3x plus 8. Over here, I factored out a 5, and I end up with that 3x plus 8. Now notice how I have a 3x plus 8 in both. So now both of these terms include that 3x plus 8, so I can factor out a 3x plus 8, and then I have these other two terms left in my other binomial that I'm multiplying. So that is how you factor by grouping. It is always going to work this way. Make sure that you have 4 terms before you factor by grouping. If we only have 3 terms, we actually want to factor in a different way. So check out the next video on how we would factor if we have 3 terms.